Hello, my name is Jorge Ciprián. I'm a master's student at Tecnológico de Monterrey, and I will be presenting a deep learning model for wildfire detection through the fusion of visible and infrared information. This is joint work with my supervisor, Gilberto Chuarris. So the motivation behind this project is that wildfires have the potential to get out of control and have a significant impact on the environment, properties, and lives. For this reason, early wildfire detection is of vital importance if we want to avoid as much damage as possible. With this in mind, the aim of the project is to perform forest fire detection in controlled datasets through a deep learning model that can take advantage of fused visible infrared information. And we hypothesize that the use of this fused information will allow us to achieve a lower false positive rate when compared to existing techniques. So the intended outcomes of this project are a dataset comprised of visible, infrared, and fused images, an optimized visible infrared image fusion technique for this proposed deep learning model, a deep learning model that can employ this fused information to perform wildfire detection in controlled datasets, and finally, a conference paper presenting the results of the project. We propose a solution model for this system that is composed of several stages. First comes the dataset generation, in which we obtain the visible and infrared image pairs. Then we explore different feature combination techniques and information fusion techniques to generate the fused images. Then with these fused images, we go into a training phase, testing different loss functions, ground truths, and architectures. We select the best performing model. And with this model, we go into a final test and fine-tuning phase to finally perform image classification. Currently, we are in the process of implementing and evaluating different image fusion techniques for the particular task of fire image fusion. So for this, we evaluate two image fusion methods on the 640 visible infrared image pairs that are present on the Corsican fire database through 4 metrics that are image entropy, correlation coefficient, peak signal to noise ratio, and structural similarity index measure. Here we can see as well some sample fused images that are produced by these methods. We refer to the first method as BGG19, and it's proposed by Lee and colleagues. And the second method is called Fusion GAN, and is proposed by Ma and colleagues. We can see the inclusion of thermal information in terms of the shape of the flame, and also of visible information in terms of texture. We can see the results across all metrics for these two evaluated methods. First of all, we can observe that on average, the BGG19 method performs better, but it does display more variability in these results. The Fusion GAN method tends to generate fused images that are closer to the source infrared images, while the BGG19 method has a more balanced approach towards including thermal and visible information. So in summary, we are motivated by the importance of wildfire detection in order to avoid as much damage as possible. We hypothesize that a deep learning model that can take advantage of fused visible infrared information can achieve a lower false positive rate when compared to existing techniques, and we propose a solution model for this system. We also evaluate and present the performance results of the two selected image fusion techniques for the particular task of fire image fusion. As a highlight, we can observe that the BGG19 method displays the best average performance, but it does present more variability in these results. Going forward, we will implement, evaluate, and compare the method proposed by Xiao and colleagues for image fusion with the two already evaluated methods. We will select the best performing one and employ it to generate the augmented fused image dataset. And with this image dataset and taking as a launching pad the architecture proposed by Xiao and colleagues, we will then generate the final deep learning model for wildfire detection. Thank you.